Hi everyone, in this video we're going to go through how to sketch parabolas in turning point form. So what we have here in the purple box is the key ideas, and then on the right hand side, because I've got to squish everything into this screen, is the Desmos calculator. So obviously you can sketch graphs on your calculator, but Desmos is a little bit more user-friendly than your calculator. So I often use it for graphing because it's a lot quicker and it's just more user-friendly. So you can see the address there, desmos.com/calculator. All right, so let's have a look at these key ideas and then we'll do a couple of questions together. So the graph of y equals x squared is a parabola. It's a parabola because the highest power of x is 2. Okay, so up until now, you've only looked at linear graphs, but you can have other powers of x. So x squared, it's a parabola. If it was x cubed, it's called a cubic. X to the power of 4 is a quartic. And then you could have other graphs like x to the power of -1, and you could have x to the power of -2. But you'll be exploring them more probably next year. Oh, sorry, definitely next year. But maybe this year, we'll see how we go. All right, anyway, let's move on. So in Desmos, I've put in, you can see here the red, I've just typed in y equals x squared. So there's our graph. So you can clearly see there's your turning point 0, 0. So your turning point is just basically your parabola is decreasing, then gets to the turning point, or we call that also a minimum, and then it starts increasing. All right, so it's a decreasing function until we get to the turning point. Then it turns around and increases again. All right, so that's what it means by the turning point. Now your turning point is, for this graph, is your axis of, the axis of symmetry is your y-axis. So the axis of symmetry just means where it splits it in two. So we're basically going down, having a vertical line is going to split it in two. So if you think of your body, if you cut yourself vertically, you would have one eye either side, one arm either side, one leg every side, etc. Whereas if I was to cut horizontally, maybe at your hips, you've got your legs and then you've got your torso and your head, and it's not symmetrical. So axis of symmetry just means you're cutting it vertically and it's symmetrical on both sides. Now, we can have transformations of the parabola. So the graph of y equals -x squared is the reflection. So I'm just going to show you that here. So if I put a negative in front of that x squared, see how it flips? So there's the positive parabola, there's a negative. Positive, negative, positive, negative, positive, negative. All right, so when there's a negative in front of your x squared, it's a negative parabola. All right, it's been reflected along the x-axis. So think about just reflecting. Oops, there we go. You could also have a reflection in the y-axis, but we're not really exploring that just yet. Okay, we're only looking at a reflection in the x-axis. All right, now the value of a, which is the coefficient of x squared, tells us what's happening to the graph. Like it's becoming either narrower or wider. Now you can see here when a is greater than 1, it becomes narrower. So let's have a look over here on Desmos. All right, so I've set up just the blue graph here. I'm going to keep the red one. It's just hidden at the moment behind the blue one, and see what happens when I increase the value of a. So see how it gets narrower. All right, it's going to get closer and closer to that y-axis the higher your value of a gets. Okay, so that's what it means by narrower. Then when a is between 0 and 1, and not equal to 0, because if it was equal to 0, you wouldn't have a parabola there. And if it was equal to 1, it would be exactly the same as x squared. So that's why it's just greater than 0 or less than 1. All right, so let's explore what happens then. So we'll go back. Oops, not that far. That's good. There we go. There's 1. All right, and now I'm decreasing it. So see how it becomes wider. Whoops, we don't want to go that wide. All right, so it's just getting wider and wider. So 0.3 is a number between 0 and 1. Now, if I keep going to 0, there you can see it's a straight line on your x-axis. And then we're getting to the negative number. So obviously it's reflected, so you can see there. and it's getting narrower and narrower as it gets less than -1. Okay, so if we just go back to -1, all right, which you can see there. So when it's less than -1, it becomes narrower, and when it's between 0 and -1, it's wider, but it's also reflected. Okay, so I'm going to turn that one off because we're going to look at other transformations. All right, now we're going to look at, in this video, this general form of the, so I should call it a general form. It's a turning point form of a parabola. And the reason it's called turning point is because we can see key features, which in one of those features is the turning point. All right, the turning point is HK. So I might just actually rub that out and use different highlighters. So I'm going to use yellow. So see how H is here. So that, oh gosh, that value of H is your X coordinate of the turning point. And let's do K in blue. So K is the Y coordinate of your turning point. Now, as you begin to learn these, you're going to get mixed up with this negative here. All right, so I'm going to kind of, when we get to things like that, I'm going to just really explain it to you because it's going to confuse you. All right, be prepared to get confused, but you'll be okay. All right, so other features, let's have a quick look. All right, your axis of symmetry is X equals H. So basically, if I go back to Desmos, I'm going to use my slider for H. So see how, oops, it would help if I actually turn the graph on. And why have we, oh, do you know why we've gone up? Because I've got a value of K, which is 1. So let's turn K to 0 and let's put H at 0. Okay, so there it is at the original spot. So it's just X squared. So as I increase H, it shifts along the X axis. So see it moving. So if I make it 4, the axis of symmetry is at X equals 4 or X equals H. All right, so you can see what I've written over here in our pebble box. All right, the next dot point, if H and K are positive, then the graph is obtained from the, oh, this might be a little bit confusing. So let's just highlight the important part. So if H and K are positive, then basically we're translating H units in the positive direction of the X axis and K units in the positive direction of the Y axis. All right, so we've written these notes before when we in our first lesson on quadratics, but basically H shifts it left or right, or positive direction of the X axis or negative direction, and your value of K goes up or down. All right, so, and that's what that last dot point says. So H, remember, is just shifting it left or right. All right, see it move. All right, let's put it back in its original spot. And then K goes up or down. Okay, so see how it's moving. So you can move it down. So maybe we can move it down -2 and we can shift it across, maybe 3. All right, and there's your parabola. Now today we're not going to look at changing A other than making it negative, just because that might just be a little bit too advanced for what we're doing. You know, this is just a beginning or an introduction to turning point form. Okay, so just remembering that H shifts it left or right and K is up or down. All right, so what we're going to do, we're not going to do every single question. We've already started this, and I'm going to keep Desmos on there because it's always good to have a look at the graph. So we're going to go through all these things and eventually we're going to sketch the graph. So our main aim here is to sketch the graph, but also identify the transformations. All right, and it's also important to get the turning point. All these things are very important. All right, so this very first one, we've got y equals x squared plus 5x plus 4. So when you look at that, it's not in turning point form. All right, it's not in the form y equals a times x minus h squared plus k. It's in what we call expanded form. So, and I'm going to write the turning point form here, just so we can remember what it looks like. All right, so this is turning point form. So we need to get from this to this. And the way that we do that is we complete the square. Now this one here is going to give us fractions. All right, but we did do a complete the square in class without fractions. So I'm going to do this one because it's a little bit harder. Oh, it's not, I suppose not. I mean, the process is still the same. You're just dealing with fractions, but sometimes when we're dealing with fractions or negative numbers, they can be a little bit scary. All right, so the very first dot point in our list of things we need to do is find the y-intercept. So remember your y-intercept is when x equals 0. So when it's in expanded form, so your y-intercept is when x equals 0. So if we substitute 0 into this expression, we're going to get y equals 4. So your coordinates of your turning point, 0, 4. All right, so what I might do is put that on Desmos. I'm going to turn that purple one off, and I'm going to put this whole expanded plus 4, just so we can see it as we go. So here is that, oops, no, what are we doing? The y-intercept, there it is at 0, 4. Okay, so we just worked it out. So you're not going to always have your calculator, so you need to be able to do this without technology, but we're going to do both at the same time so that the technology supports what you're learning, but don't rely just on the technology. You need to be able to do this by hand. All right, so let's complete the square. I might do that in a different color. Let's do that in purple. All right, so when we're completing the square, we're going to take the coefficient of x, which is 5, so it's going to be plus 5 on 2 squared, and then minus 5 on 2 squared plus 4. Now we've done completing the square when we did quadratic, so I'm not going to go through that process. So, you can go through your notes. I can help you in class with it, but I'm not going to spend time in this video going over completing the square. All right, let's just tidy this up. Now, 5 squared is 25, and 2 squared is 4, so I'm going to have minus 25 on 4. Now, because I'm going to be adding another number, I'm going to change that 4 to be 16 over 4. Now, the reason I did that is so I've got the same denominator. So when I'm adding or subtracting fractions, it's much easier to do it when you've got the same denominator. All right, so let's write that down. All right, so minus 25 on 4 plus 16 on 4, it's minus 9 on 4. So there's our equation, our quadratic equation in turning point form. So we can see the values of h and k and a. A is just 1, but I think I said before a is going to be either 1 or negative 1 for these questions. Now, this is where it gets tricky. So remember, we have this minus sign in here. So when you're doing it in turning point form, think of a plus as 2 negatives. All right, and that's going to help you better identify what h is. So in your general form or your turning point form, it's x minus. So we want x minus, and then we need to clearly see what h is. So in this case, h is negative 5 on 2. Now, I know it looks a little bit different to the one before it. That's only because I've changed this plus to 2 negative signs. All right, just so we can clearly see that h is equal to negative 5 on 2. So I'm going to write that next to it, maybe in blue, so it stands out. So h is negative 5 on 2, and k is negative 9 on 4. Now, you want to do that as decimals. Negative 5 on 2 is negative 2.5, and negative 9 on 4 is equal to negative 2.25. Because I'm just doing that because on Desmos it's going to give us the decimal answer. So let's go back over to Desmos. So this turning point. All right, see how your h is negative 2.5, your x coordinate of your turning point, and then the y coordinate or your value of k is negative 2.25. All right, so that's your turning point. All right, what else do we have to do? Transformations. All right, so your transformations, what can I write that in? Let's do it in pink. All right, so transformations. Whoops, can't spell transformations. Okay, so remember we've got the H and the K. We did that here. All right, sorry, I'm drawing on my graph a little bit. But that H, because it's negative, it's gone to the left. So if we just have a look, let's put you in, and I'm just going to change it to 1. Where are you? All right, so if we look at our blue graph just being y equals x squared, so you can see the red graph, the one that we've just sketched, has moved to get to this point, negative 2.5, negative 2.25. So there's the turning point. Oops, not that one, excuse me. 0, 0 has now become negative 2.5, negative 2.25. So to get from this point here at 0, 0, you've gone to the left 2.5 and down 2.25. So your transformations, you've gone to the left 2.5 units and down 2.25 units. Now notice I got rid of the negative sign because you don't like, let's say, I don't know, you're going in a lift, elevator, and you're going down. So you're up maybe on the 20th floor. You don't say I'm going down negative 20 flights to get to the lobby, all right? You just say you're going down 20 flights. So we're just shifting down 2.25, all right? So just remember that negative sign is the same as saying down or in the negative direction, which is probably the more formal language we need to use, but for now we're right, just using left, right, up, down. And left is 2.5 units. So instead of saying in the negative direction of the x-axis, you can also just say to the left. All right, the last thing we need to do is the x-intercept or intercepts. So remember with the parabolas, you can have either 2 x-intercepts. So in this one, it's got 2. You can have 1, that means it's sitting on the x-axis, or you could have none, so it's sitting above. All right, so x-intercepts, we need to let y equal 0. All right, so we're going to have x squared plus 5x plus 4 equals 0. And this is where you use your null factor law. So first of all, we just need to factorize it. You can use the quadratic formula if you want to, but this is quite an obviously easy one to factorize. So it's going to be x plus 4, x plus 1. All right, so 2 numbers that multiply to give you 4 and add to give you 5. So we're going to have our x-intercepts are at negative 4 and x equals negative 1. And you can see those 2 points here. All right, there's negative 4 and there's, was there, negative 1. All right, so when you're sketching, let's get rid of the blue one. All right, so when you're sketching it, you kind of need these key features. All right, you need 0, 4, your y-intercept. You need your turning point. All right, so just be careful with that because we are dealing with fractions. Your x-intercepts, negative 1, 0, and negative 4, 0. And you need to make sure your parabola actually looks like a parabola. So just take your time going between those points and try to make it look as symmetrical as possible. All right, I'm going to do a question now using your calculator. All right, so I know we've used Desmos, but we're going to just say, all right, let's pretend you couldn't complete the square. I'm just trying to think of one we could do. Maybe we'll do this one. No, let's do one with a negative because I know there's some negatives towards the end. Let's do this one. All right, now you can just do it straight from here. Now I know just by looking at this parabola that it's a negative parabola. So see how the coefficient of x squared is a negative number. It's negative 1. So when it's negative, it's going to be reflected in the x-axis. So let's have a look at what that looks like on Desmos before we get the calculator out. Minus 5x minus 4. Okay, so see, it's upside down. It's been reflected. All right, we can also see the key features. So there's, oh, it's just pretty similar to the one we just did. It's just been reflected. There we go. It's interesting. So same x-intercepts, and there's your y-intercept. So this graph here is actually the reflection of the one we just did, which is pretty cool. But let's do this on the calculator anyway. All right, so when dealing with, if you're doing this one by hand, like if you were completing the square, you just take that negative out as a common factor. All right, and then you complete the square with what we have inside it. And you could take out any common factor. So let's say 2 was common. That means then you would have a value of a. Okay, but I don't think any of these. Oh, there we go. You would take -2 out as a common factor. So for this one, you would have y equals -2 x squared plus 2x plus 5. All right, so you would do that, complete the square with that one. Okay, whoops. Let's go back to this. Oh, there we go. All right, let's get the calculator out. So we know what it looks like. Let's get the calculator. All right. Now, you can just use the equation all the time, but eventually you're going to use quite complicated functions, and it's usually in your calculator easier to define it, especially if you're using it for multiple things instead of typing it, although you can copy and paste in your calculator, which is great, but it's easier just to define it, especially if you're also working with multiple functions. So what we need to do is, first of all, I need you to understand that this y, another way of writing y is f of x. So when you head towards methods, you'll see y equals still, but we use the function notation f of x. So in your calculator, we're going to use f of x. All right, so let's get the keyboard up. And I never know which menu it's under. There it is, Math 3, define. All right, so the define function just says to the calculator, hey buddy, I want you to store this equation for me. All right, I don't want to keep typing it, I'm over typing it, can you just do it for me? Can you just keep it in your memory, so every time I type f of x, you know what to do? And the calculator goes, sure. So f of x equals, so we're not doing y equals, it's f of x equals. All right, let's get used to some function notation. And I'm going to write it as it was initially with the negatives because, you know, why not? Either way is fine though. All right, and then it says done. Now, if it doesn't say done, you've made an error. All right, and it should be quite noticeable because we haven't done anything too complicated there. It's done. Now, if you've had a lot of stuff on your calculator, it might be a good idea just to clear all before you start, because you may have done stuff maybe months and months ago and it's still on your calculator. And if you ask your calculator to do something and it's got something from months and months and months ago, it's going to remember that. All right, this calculator, remember, you've told it before, remember this function. It remembers everything. So you need to clear it. Okay, so just define. All right, clear it, then do your define. If you were to do it again, another define, it is going to overwrite this. All right, you don't always have to clear it, but sometimes it's just a good idea to clear it, because if you've got too much in there, it uses the memory, the calculator's memory, and it just slows it down. All right, I'm getting off track now. So the first thing we need to do is find the y-intercept. All right, so remember your y-intercept, we let x equal 0. Now, with your calculator, because we've already defined it, see how we've got f of x? You can just say, all right, I want you to do f when x equals 0. You can ask it to calculate any value, substitute in any value of x, just by putting it in that bracket. There it is, -4, and let's just get back to decimals. And remember, there it is, whoops, at -4. All right, so quickly you can find it. I mean, we can also see here that it's the constant is -4, but you know, we're learning the basics with easy stuff, so then you can apply it to the harder stuff. All right, the next thing we need to do is transpose it to get into turning point form. So turning point form. All right, now thing with your calculator, now the other brand of calculator, the TI, does completing the square, but we have to be a little bit more, I'm just going to say shifty, but shifty is not the right word, maybe a little bit smarter and go about it a different way. So we're going to actually just find what the turning point is. So if you go to interactive, oh, my dog's just barking at the possums. What am I going to? Calculation, and then F-min, F-max. Now, if it's a negative parabola like this one, our high point is a maximum. If it was a positive parabola, it's a minimum. All right, so if I get rid of this negative sign, all right, you'll see we're down the bottom there, that's a minimum. All right, put the negative back. All right, it's a maximum. So that's a maximum turning point. So on your calculator, you need to choose F-max if it's a negative parabola. All right, so your expression, you could type it all in again, but we said, hey, calculator, can you just remember it for me? And you just type f of x, all good in the hood. The variable is x, which is fine, and the negative infinity to infinity. Look, we're just dealing with parabolas, but you can have graphs with multiple turning points. All right, so cubics can have multiple turning points, but parabolas only have one. So we don't need to really think about that start and end, which is awesome. All right, just go okay. And then you can see we've got a turning point of 2.25 and x equals negative 2.5. Now this is a little bit annoying because this isn't coordinates. All right, it's telling us that the maximum value is 2.25. So that's your y value and then x equals. So it's a little bit more of a hint because we can see x equals negative 2.5. Oops. Let's write that down properly. Negative 2.5. And then your y coordinate is 2.25. All right, so let's go to Desmos. Come on, Desmos. Hello. There we go. And there's your, oops, not quite. Let's try to get it properly. There it is there. All right, negative 2.5, 2.25. Now, remember before, I'm telling you to remember a lot, aren't I? All right, so this is with your turning point. This is your value of h, and this is your value of k. So what we can do is say, all right, I'm going to have my parabola. So h is negative 2.25. So don't forget it's x minus h. So h in this case is negative 2.5. Close the bracket. Squared plus k, so 2.25. All right, your value of a in this case is negative 1. Now, if you didn't know what a was, you would have to, I'm just thinking a minute. Sorry, I'm just thinking of two things at once. What I'm going to say to you, but also something else. So if you had to find a, obviously you just substitute in a value of x, y, and solve for a. Okay, but we're not doing that. Yeah, so we just can say, all right, x plus 2.5 squared plus 2.25. So what I was saying with a, sorry, I probably should have focused more on that. You can just substitute in at any point. All right, you've got your x and your y coordinate on your graph. That isn't the turning point. All right, so we could use the y-intercept, okay, because we know what that is, and that can give you the value of a. My dog is like tap dancing in the lounge room. Okay, so that's how you can get it into turning point form using your calculator. So just going back here, going to interactive, calculation, min max. So minimum if it's a positive parabola, maximum if it's a negative parabola. And then you'll see it gives you the maximum value when x is negative 2.5. So the maximum value is 2.25, that's your y, and x equals negative 2.5. All right, So there's our graph. The last thing we need to do is these x coordinates. All right, just going to write that down. So x coordinates, well, sorry, not x coordinates, x intercepts. Let y equal 0. So on your calculator, let's get the calculator. Now I'm just going to quickly try something. I don't know whether this is going to work. Oh, no, it's not going to work. So just ignore what I just did. I was going to see if it would do it without me pressing solve. So whenever you have to solve an equation, you just go to solve, pretty straightforward. And we want y equals 0. So remember we said before, y is the same as f of x. So we can just say f of x equals 0. Now what I did before is the calculator just did that for me. All right, so that's effectively the same as this. My dog's going a bit crazy. F of x equals 0. All right, so remember we told the calculator store it in. You can see it has stored it. It's remembered. Thank you. All right, so solve and then comma x because we're solving for x. And there's your x-intercepts, -4 and -1. So instead of going ahead and factorizing it, which is not a hard one to factorize, but you're going to come across ones that are harder. All right, the last thing I want to show you on your calculator, I'm just conscious I didn't really want this video to go longer than 30 minutes, but you know, lucky you to listen to me for a little bit longer. All right, so on this page, oh, sorry, I didn't show you what I was doing. So menu, graph and table. All right, and then at y equals, we're just going to do f of x. All right, I've already told the calculator, hey buddy, can you store f of x for me? I said, no worries. And then we just go to the parabola. Oh, I can hardly see it. So if we just go down here to resize, it's a little bit easier to see. And you can shift this if you wanted to. What are you going to do? I was wondering what that was. All right, so if you wanted to go back to the graphing screen, not the graphing screen, entering in your functions, it's just this top corner one, so there. You can also change, I need to go back to my graph. So I was on this screen, see how it's highlighting the different parts? It's a split screen. So I can just go to zoom. Another one you could do, I think, is standard. Might be a little bit easier to see. All right, so there's our parabola, same as what it was on Desmos, which is good. You always want to get the same thing. All right, so we can find the turning point here, just going to analysis, trace. No, sorry, wrong one. What do I want? Gsolve, maximum. Or you could go to function maximum, doesn't really matter. And there it is. It's a bit small to see on the screen, but you know, if you've got your calculator in front of you. So you can see it that way as well. You can get HK that way. The other things you can do is if we're using trace, it's going to ask you, so first of all, it's found that, what am I talking about? The y-intercept, but you can find any point on here. So if I just press the number 5, all right, it's going to say enter value, x value equals 5. So I just press the number and then it gives us the corresponding y value. The last thing you should be able to do is the x-intercepts. All right, so, sorry, I should have told you what I just pressed. Gsolve, root. All right, so we've got -4, and if you just go across, it does the other one. All right, so -4 and -1. Okay, so many ways you can learn about parabolas. All right, doing it by hand, which is really, really important. Doing it on your calculator, equally important. But using Desmos is a really good graphing thing. You know, it's quick. Sometimes the calculator can be a little bit tedious. All right, I'm going to leave you there. And make sure you finish the rest of the sheet, doing it whilst graphing it, either on Desmos or your calculator. Make sure you're doing some questions by completing the square. You don't want to just do everything with technology, but you also don't want to do everything by hand. So make sure you're doing a nice combination. All right.